Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts for pushing the boundaries of innovation. Whether you're a student or professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Nattoo, who holds a master's in electrical engineering from Stanford, where she is currently working on her Ph.D. How are you doing today?
Hi, I'm great. Thanks for having me on, Rohan.
Thanks for coming on the podcast. So to start off, I wanted to ask what made you choose your major of electrical engineering for your bachelor's?
I have one of those rare cases where I knew exactly what I wanted to do, like as soon as I was like applying for college. Like a lot of my colleagues told me like that they were like, undecided in engineering for a while. But for me, I did engineering as an elective in undergrad. Well, not undergrad, high school. I got to go back twice now because I'm in grad school now. So when I was in high school, I had an engineering teacher who started the same year as me, and I had to pick an elective. Ended up didn't really want to do some of the other ones, so I picked engineering. And I fell in love with it. I was doing a lot of like CAD, like computer aided design, and CAM, computer aided milling, a couple different things with basically wood shop and machining, but more advanced. So that was kind of like right before 3D printers, but they still had CAD, but it was not being used to like extrude. It was just for like cutting things. And so I got my certifications in SolidWorks, which is a CAD software, and Mastercam, with the help of my engineering teacher. So I actually could have gotten a job right out of high school doing that if I wanted to, because like any machine shop, like that's like a certification that you like need to get a job there. But I wanted to go for my bachelor's degree, and so I did that instead. That's a little bit of a pattern for me. Trying to do something, even though I could get a job, trying to do something else. Um, yeah, so once I decided to apply for college, I was like, I definitely want to do engineering because like that's what I've been doing and I love making things. And it kind of sounds silly saying it now, but like back then was at the kind of the beginning of when I don't know if you know MKBHD. He's like a YouTuber who does tech reviews. He was just starting around then, and I would like watch some of his videos sometimes, and I thought they were the coolest thing. I was like reviewing cell phones and like what's inside of them. And so I was really into like the technology of cell phones. And so that led me down the path of like doing robotics. So I did like some robotics competitions in high school. And then from there I was like, okay, so that kind of is either mechanical engineering or electrical engineering. But because I'm interested in more like the circuits and like how they work, I decided on electrical engineering. So it was a bit of a windy path, but I figured it out in like high school before I even applied. So
Yeah.
yeah,
And what was your experience like while doing your bachelor's?
my bachelor's degree was a ride. It was really hard, I would say. I didn't know it at the time, but a lot of times when I would tell people, I was like, "Oh, my major is electrical engineering." They're like, "That's really hard." But weirdly, I didn't know that when I chose it as my degree. I was just like, cell phones are fun and I want to know how to make them. So that was basically like my decision making process on that one.
Yeah.
Yeah, so yeah, that was basically, sorry, I got distracted for a second. What'd you say? Can you
Yeah.
repeat the
So,
question so I can, yeah.
uh, yeah. And then while doing your bachelor's, were there any outside opportunities you did, such as internships?
Yeah, I did a couple internships while I was in college. My first summer, I didn't end up doing an internship. I actually worked a job because I didn't realize I was supposed to be looking for an internship. which was an interesting situation. I got into, I mean, I'm a first generation student, so neither of my parents have college degrees. They immigrated here from Jamaica and then got more like service jobs in like the banking industry. So, uh, engineering and even doing a college degree was like a really new thing for my family. I think yeah. After me, I think like one other cousin has like a computer science degree now as well. But yeah, I'm basically the only engineer in my family, I would say. Um, and so my first summer, I didn't know that most people were getting internships. I just heard about people having internships as the summer was approaching and people were about to go. So I decided to figure out and try and get a job for the summer and ended up working at a coding camp for kids. I think it was like 6 to 13 was the age range for that. So basically elementary, middle schoolers. Which was an interesting mix of students. That company also doesn't exist anymore. Um, but while I worked there, I was teaching these small kids like Python and coding in Minecraft. But that was kind of a hard job because it ended up being more daycare than teaching them coding. But I had a couple students who were really like invested. There's a couple of girls who were like maybe like 10, 11 who really wanted to make an app. So I tried to help them like learn how to code it and how to like build an app visually and the different parts of it. So that was like one good experience from that. And like we basically got all the way up to the point of like actually making an app because you have to like pay, at the time you had to pay to build in the app building software. I think it's like Xcode for Apple, and so we didn't want to do that. But I think it was nice. That was kind of one of my first experiences with like mentoring, which became really big for me, especially later, like working with students and helping them figure out what they want to do. But yeah, after that experience, I wanted to have an actual internship for the summer. And so I went to my student services office, and they had a person there who could like help you with like figuring out internships and like classes, anything like that students needed really. And she recommended that I try an REU, which stands for a research experience for undergrads. And basically, an REU is like an internship, but instead of being at a company, you're at a university. And so that was the summer that I did my first REU, which is at Vanderbilt, which is in Nashville, Tennessee. It's a really great place. It actually, it sounds like a bit of a cliche, but it looks like Hogwarts. It's like very old timey and like beautiful. And it was the summertime, so I avoided the snow, thankfully. But all the buildings looked the same. It was impossible to get around, but the people there were amazing. And the city was just like so fun to like walk around and kind of get to know other students who were also interested in research, which I didn't know I was interested in at the time, but by the end of the summer, I definitely knew. So I did another internship like that the next summer, this time in Orlando, which was a little bit closer to home. But also kind of gave me some new experiences. Like both of my research internships that I did were on very different topics. So the one at Vanderbilt was about like photonics, like light particles. And then my internship at UCF in Orlando was more about 3D printing, um, like CAD design for electronics. So instead of using like thinking about photons, I was thinking about electrons, which are two different types of particles that you can think about still within the sphere of electrical engineering, which is why I think my major is one of the best majors because it's like so broad, so many different things you can do within the same major.
Yeah. And what were you doing with photons?
Okay, so that was an interesting one. So we were basically using light. and the way that light diffracts through particles to detect different levels of anything, any particle that you're like thinking about. So we would take this material. So I don't know if you're familiar with silicon, but it's basically the thing that most electronics are made out of. Most transistors are made of silicon, which is basically sand that's been melted down and purified to the purified form of silicon. So sand is silicon and oxygen, basically. So taking out the oxygen, purifying the silicon, then you can make anything with it, which is a really cool material. But the way we were using silicon was pulsing. So there's this type of acid called hydrofluoric acid, HF. It's very dangerous. If you ask anyone about HF, they might get a little bit scared because it is calcium seeking. So if you get a little bit of HF like on your hand, it'll seek your bones and start eating your bones away. So if you ever have a hydrofluoric acid like spill, you have to have or even hold the chemical, you have to have this calcium, I think it's called gluconate. I can't remember the exact name, but it's like some type of calcium like cream that you're supposed to put on. But yeah, it was kind of scary but also fun that I was like I was like 19 or 20 at the time, and I was like playing with like this really dangerous chemical. But we were doing cool things with it. Basically, we would pulse the hydrofluoric acid through the silicon, and it would create these tiny little holes. And you could change the size of the holes based on like how fast or slow you like pulse the current through. Um, and if you make big holes, then that means that big particles could be trapped in the holes. And the reflective index, which is basically just like a value that tells you how much light will bend when it goes through a material. So I think most reflective indexes are based off of air, but a very good example of this, I think the refractive index of air is like 0, and then water is like 1. So when you reflect light through it, um, you can see the light bending in water, and that the reason for that is the difference in refractive index. So that's an effect that you can see like in your everyday life, basically. And I was studying that, but on a more complicated scale of materials and holes and filling the holes and then seeing how the refractive index changed. And we would monitor that with a cell phone by isolating like how the color changes. So I really liked working with these films because while if you would hold them up, they kind of look like a rainbow because of all the different refractive indexes. So basically, because the light was reflecting at a different angle, it created the visual effect of different colors. And so all of my samples that year, they're just like rainbow circles that I would like then do other things with. And I love colors, so that was really fun for me.
Yeah. So after finishing your bachelor's, or I guess when during your bachelor's did you decide that you wanted to get even higher education and get a master's and PhD?
Yeah. So I would probably say it was about the same time that I was finishing up that first internship. I'm moving into the next one. Part of my reasoning behind that, because originally I was gonna do like when I was deciding on internships, I was like, I want to try different things. So I want to try a research internship and then I want to try an industry internship. But once I did my first research internship and the idea of doing a PhD came into my head, that was harder to not continue down. I mean, especially after I was taking this class. So one of the benefits of my university, I think I haven't talked about this yet, is that some universities, if they're smaller, like because University of Miami is a private school, the class size is also smaller, so you get more access to your professors. Like most of my classes at U Miami were like maybe like 10 people, and I know that at a lot of bigger schools, sometimes your core classes can have like hundreds of people. And so if it's like one professor and hundreds of people, they're probably not going to talk to everybody in the class. But like if it's one person, like one professor and then 10 people, then they can like you can after class you can go up and talk to them, ask them questions, and like even outside of office hours. And so I would do that a lot. And there was one professor that like I really liked talking to and who always had gave me like really good help and advice. Um, Dr. Murthy at Miami, he was like a great mentor. And uh, I after like talking to him for a while, he was like, like you would make a really good PhD student. And I had not even considered it. I had like maybe like thought about it a little bit, but I was like, I don't know. I've never done this research thing. This is pretty new. And like after he said that, I started thinking about it like more actively. I was like, well, he has a PhD because like all professors at universities have that's like a requirement for most professor jobs. There's like lecturers where you don't need a PhD, but to have the title professor, you have to be a PhD. So like Dr. Murthy had a PhD, and so him saying that he thought I could do it made me feel like I could do it. And so he helped me apply for the other RU that I ended up going to at the University of Central Florida. And so, yeah, and then he also helped me when I was applying for grad school because you have to write the essays, um, and take certain exams, and I didn't really know how to do that. And so he was like really helpful and like making me feel like I could definitely do this. And which is why I feel so strongly about mentorship because the people that have mentored me like very hands-on and actively have helped me so much in figuring out what I want to do and how to like build my career. So I always love that I had the opportunity to like help other people with that as well.
Yeah. So what was the whole process like while applying to grad schools? Did you apply for a PhD or do you just apply for the master's and then do the PhD later?
Yeah, so my game plan going into it, I knew that um there like because you definitely have to make a game plan when applying to grad school. Everybody has their different one, but mine was I wanted to apply for the PhD. I knew some schools you could apply for the master's and then go to the PhD after, but for me, I knew I wanted the PhD, and so at least if I applied to the PhD, um, yeah, like I would try and maybe get that. And if I didn't get PhD offers, sometimes they'll give you a master's offer if you don't get the if you apply PhD and don't get it. So that was kind of like my plan. I wouldn't even say B. Probably plan C was that if I didn't get the PhD offer, I'd try and take a master's and turn it into a PhD. So, because you can't go the other way. You can't, if you don't get the master's, they're not going to send your application for the PhD. So, that's kind of like how I thought about it. And then I started making a list of the schools that I would be interested in going to. I had some interesting parameters for choosing my school, but one of them was definitely that I am from South Florida. I've never lived somewhere where it snowed. I didn't think that I could go to a school where it snowed. Um, so I didn't apply anywhere where it snowed, which is why I never applied to MIT. Not because I don't think they're a good school, but it's just like I could not be in the snow. Uh, so I that ended up narrowing it down to like I think I was applying to schools like mostly on the West Coast, as low as like Austin, because Austin, Texas has a good engineering school. And they were scouting me as well from undergrad. There was a guy who came and was like, "You should apply here." So I applied to that one, but then outside of that, I just applied to California schools. I think, yeah. So I ended up applying to Stanford, Berkeley, UCLA, USC, Caltech, and then yeah, Austin. Oh, I didn't even apply to Austin. So a lot of the deadlines I had to make a calendar for it. So this was my first time doing this, and like obviously it's most people's first time applying for grad school when they do it. But I missed one of the deadlines. I think it was the Austin one, and that's why I didn't end up doing that one. But the California ones are usually like later or something like that. Um, but yeah, if I was going to do it again, I would definitely start making my list earlier. Like I think I started like maybe September. And I probably should have started like May, June, honestly, to just make sure I had all my deadlines and I didn't like miss any of them because there are so many opportunities for like money and grants that you could apply for as long as you're like early enough for it. So I would definitely recommend that, but I didn't end up being that early. So I applied to five. So that was I think November is usually when those go in, around November, December. And then, yeah, that was an interesting time for me as well because I had a lot of personal things go on. Like one of my uh like relatives, my grandmother actually who raised me passed away around the same time. So it was definitely a hard time, like applying for grad school, but also dealing with like real life. But I mean, just thinking back, I was like very resilient, and I think that probably came through in my application because uh, being in the PhD now, I realize more and more how much being resilient is a key ingredient for being a good grad student. That is not often talked about. Like, you have to be a really strong person to get through the hundreds of failed experiments that you have before one works. Um, yeah, but just going back to the grad school thing, yeah, so I applied to those five schools, and then around January, February, I heard back from a couple um, for interviews. I think I had an interview for Stanford, I had an interview for Caltech, um, UCA, yeah, UCLA, I had one, and USC. And so basically, it was either like a professor or a grad student would call me and then ask me some questions about like my research experiments, or just kind of give me like a run through example project and like what I would do in that situation. So kind of like tech interviews, but like a little bit more low key than a tech interview. Um, and then after that is when I got kind of my offers. So, like, which schools were offering me admittance. And then, if you got admitted, then you could go to their admitted student weekend, which was basically when they flew everyone in who was admitted to the school to kind of get a tour and get a better idea if that's like the school they want to go to. So, it's like you get admitted to a school around like February, March, and then you have to decide by like April. So you had a little bit of time to choose, and a lot of them would fly you in for free and then wine and dine you, try and convince you to go to their grad school, which was like a fun experience. Because I never did that for undergrad. Like I know that like you can like pay to go visit undergrads, but I never did that in undergrad. I just tried to find a good school that was close by. So this was my first experience with that, and it was really fun. And the ones that I got into were Stanford, Berkeley, and UCLA. I never heard back from Caltech, which I wasn't too sad about, like, because I heard that like you have to have a really specific project. So if your project ideas like don't align with like the project they already have there, you're like unlikely to get in. Um, and they just have very few professors there. It's a small school. So yeah, that wasn't too bad. And then USC, they didn't offer me a PhD, but they ended up offering me a master's. But it was fine because I already had like the other three schools, like which were not bad choices at all,
Yeah.
especially in engineering. um, yeah, I think in engineering, electrical engineering, people always say that the number one school in electrical engineering is either Stanford, Berkeley, or MIT. So I had two of those. on my roster to choose from. And I wasn't going to go to MIT because it snows there. So I basically had all three. I mean, I never applied to MIT, but yeah.
Yeah.
So it wasn't bad choices to choose from. And then yeah, in the end, I ended up coming to Stanford because um, Stanford and Berkeley were really close options for me, and they're also close geographically. It's like an hour drive over to Berkeley from Stanford. But yeah.
Yeah. So what was your experience like while getting your master's, and what's your research been like while doing your PhD?
Yeah, so I got my master's during a really interesting time because I started at Stanford June of 2019, and then halfway through, everything shut down and we went into lockdown, which was great because I had barely finished my first year of grad school and I ended up going home. So I went home for a couple months because I was just basically here in my like studio by myself and I didn't want to be by myself. So I flew to Florida and I was there for a while doing online classes. So before all of that happened, grad school was hard. Even before that, because my first quarter at Stanford, I was taking quantum mechanics, device physics, and I was also doing research. Um, yeah, it was just those three, and that was a lot of work to be doing.
And
To
were you
take
already
those two
doing your
classes,
PhD research?
yeah, I had already started. Yeah, I had already started, so I was doing my research, and then these two really hard classes at the same time. And in undergrad, we were on the semester system. So that means that you take a class for 15 weeks and then you have your final exam at the end. In the quarter system, which Stanford is on, I think Berkeley is also quarter system. Um, it might actually no, I don't think so. Some of the UC schools are a quarter system, but a quarter system, instead of 15 weeks, you get 10 weeks for the same subject. So everything's so much faster. So imagine like 15 weeks of content pushed into 10 weeks, and then you have the same final exam at the end. So you have to learn things pretty fast, and it was really, really fast for me. And I ended up doing okay at the end, but I was just like, wow, that was a lot of work. And that was my first grad school experience, which I didn't think grad school was going to be easy, but I didn't realize how hard it was going to be, at least. Yeah.
Yeah. So what's your PhD research about, and how did you kind of come up with your thesis and all the stuff at the beginning of it?
Yeah, so I got pretty lucky in that I got to come early. Usually you start the PhD around September when the autumn quarter starts. But I actually started in summer. So instead of autumn of 2019, I started in summer. So I graduated in May of 2019, and then I was at Stanford like less than a month later, in June of 2019. So I got to start working on my research a little bit earlier, without like having the classes. So I got to experience Stanford like just like as is without the classes yet, which was, thinking about it like in hindsight, that was like a good option because the classes were so intense that like being able to start my research a little bit before gave me a little bit of a heads up. That was pretty good for that. And I also started getting paid, which was great because being in undergrad and not really getting paid much was kind of tough. So having like a little bit of a salary was nice. But I got to get to know the campus, meet new people, work on my research. And back then, the research that I was doing was related to flexible electronics. I was really interested in wearable electronics, and thinking about how to make those types of circuits on a polymer. which is why I chose my lab originally. I'm currently in Eric Poff's lab at Stanford. His work tends to focus a lot on uh, thermal management. Well, in the past has been a lot of thermal management for like low dimensional materials, but now we just have expanded into just like all sorts of topics related to 2D materials. I'll call them 2D materials, but they're also referred to as two-dimensional materials. And they're a class of materials that is relatively new, actually. Um, and I can kind of explain what I mean by that because it's hard to kind of like just imagine that just from the name. So the most common, like our most popular 2D material is graphene. Have you heard of graphene before?
Yeah.
Yeah, so yeah, that's good that you're familiar with graphene, so you'll kind of get the kind of general idea of where I'm coming from. But just to kind of make it more clear, um, when you're writing with um, a pencil is made of graphite. When you write on the paper, like layers of graphite are coming off on the paper that's creating the mark. And so if you took that graphite, those layers of graphite and isolated it, so it was very just one single layer of graphite, you have graphene, which is just one single layer of atomic carbon. And it was found to be like a superconducting material in like the 2010s or something like that, and got the Nobel Prize actually in like I think 2012, which is somewhat recently. So that was a really interesting case of discovering a new material. But that kind of started this whole class of materials called 2D materials. So they're atomically layered materials that you can isolate each layer from itself, from like a bulk. So in the idea of a pencil, your bulk is that graphite and a single layer is your graphene. So the materials that I work with, which are TMDs, a transition metal dicogenide, it's instead of just one atom, it's three atoms. So it's 2D in the way that it only has dimensions in X this way and this way, like laterally, but out of plane, it's only either one to like, I think 5 atoms thick, which is very, very thin. Like that's the atomic limit of all materials. So instead of calling it a bulk or material, it's called 2D for that reason. So in my class of materials, TMDs, it's a transition metal, which if you look on a periodic table, there's a column that is labeled like the transition metals. Well, there is columns that are a part of the transition metals, I would say, but there's like posts and then there's kind of like in a mix. So some examples of these materials are like indium, tungsten, molybdenum. Yeah, those are the main that I can think of right now that have like four. And then there is what I meant to say was that there's a column called chalcogens. That's the one that has its own single album column. And so the chalcogens are like sulfur, selenium, and tellurium. And so if you have one atom of a transition metal and sandwiched by 2 atoms of a chalcogen, you create a TMD. So that's transition metal dichalcogenide because there's 2 chalcogenides. That's like chemistry, which was my weakest subject, but the thing I talk about the most now is a lot of chemistry. Um, yeah, so those materials turn out to be really good semiconductors. So I was talking about silicon earlier when I was telling you about like the processing that I did silicon in my internship. Uh, Silicon is the traditional semiconductor that we use nowadays, but for forward looking, we can't thin down silicon enough to still be a viable like option in commercial electronics. So we're looking for alternatives to either augment or replace silicon. And TMDs are a really viable option that like a lot of the semiconductor industry is like looking at for the next like 20, 30 years. So it's a really good field to kind of be in because it's like burgeoning tech, like things that are like not right now, but for the future, and definitely will be like useful skills to have. So that's why I think research is really interesting because it kind of places you in those points of being at the very forefront of like these really cool industries.
Yeah. So right now, what are your current plans for after your PhD? Do you know if you want to stay in academia or move out in the industry?
Yeah, that's a lot of that's something I've thought about so much. I think some of the things that have made me kind of go back and forth. Like I mentioned before that I'm really interested in mentorship and really motivated by mentorship. And I've done a lot of experiences working with undergraduate students to see like how I would like that experience because that's a lot of what you do as a professor is your research if you're a research professor, but then also working with students. And then there's specifically teaching related roles in academia. That's just about spreading like knowledge and information to the next generation from experts. So that's kind of like my professors from the University of Miami. That type of position is appealing to me because I find that I'm pretty good. I like to think that I'm pretty good at explaining to like younger students like how to understand a concept that seems a little bit complicated, but can be like broken down in a way that's really easily understandable. And I try to work really on science communication because that's something that I'm really passionate about, which is making sure that science is accessible to those who are not are already like experts in the field because a lot of science literature is like written or talked about in a way that makes it kind of confusing to people who aren't already in the field when they could easily be broken down into more like digestible and understandable concepts so that science can be communicated effectively. And so that's something I think about a lot and have incorporated into the way that I mentor, which has been um, a lot of different things. If you look at my resume and look at my service column, I have a lot of things there because I volunteer my time a lot. But yeah, I've worked with elementary school students, like I said, teaching them Python in the past, but also very recently. And that was more effective because it was a smaller group and they actually wanted to do it. So that was a more effective time of teaching elementary school students. Like I've done like the fifth, I would say fifth to sixth, which is kind of middle school. And then like legitimately middle school, I did a workshop teaching middle school students how to put together a simple circuit. So using like jumper cables, a little battery, and a breadboard, like one of those mini breadboards, was like teaching them just how to circuit together a little LED. So they could just turn on an LED and realize that they did that and they know how a circuit works and they made their own circuit and it like increases their confidence in their ability to like do other things. And that's like the most beautiful thing to me is like seeing a student who like didn't believe in themselves like see something that they're able to do and accomplish, um, and then do something even greater with that. So that's kind of my goal in mentorship, which is why I thought a lot about academia and still think about till this day. And I think the other thing that has motivated me to think about that, like I said, I've also done, I ran an RU program. So similar to the RU program I did when I was an undergrad, I ran one at Stanford that's for students all across the world. We had students coming from like the Bahamas. We had someone coming from like, I think it was like an island. I think it was like either Tasmania or Madagascar, like one of those islands off of Africa. And then we had someone from Brazil, just like, and people who came from like all over the world too, who were just at universities in the United States too. And having that experience of bringing these people from all over the world and like watching them do research for the first time and be in a scientific like environment was really powerful. And I think that has also I want to continue work like that. I have some that reach out to me even now, like asking for advice and like writing their SOPs for grad school because some of them that applied for grad school last year. I had like 3 or 4 students get into grad school that I mentored from the previous summer. And then this upcoming summer, I have more applying. So I'm going to be helping them with applications, which is going to be fun. Um, but just seeing them like get to their dream schools in such a short timeline has been just so rewarding. And so I definitely think that I will end up in academia at some point. But I also did my PhD and really care about my research. So I want to go in industry for a little bit first. And then I think I will end up in academia at some point. Similar trajectory, I think, to my advisor, Eric Pop. He actually was in Intel for a couple years before coming to industry. I mean, before coming to academia. And then he worked at Illinois Urbana Champaign, and then Stanford poached him back here. And so now he's here. But I just like the idea of going into industry for a bit, having a little bit of the perspective, and then being able to bring it back, and then also get the opportunity to like work with students. So I would say somewhere in the middle between academia and industry.
Yeah. One question I had was, you kind of touched on it earlier, how hardworking you have to be to do a PhD. But is it
Mhm.
true that while doing one, you're like overworking, working till 3 a.m. a lot of the time, and really having to grind for those like 5, 6 years?
Yeah, yeah. So here, that's the thing is that you choose your schedule. So you could choose your schedule to be during the day, or you could choose your schedule to be, like you said, at 3 a.m. It's really up to you and like what you work best, what situations you work best under. I've known people who I never saw them during the day, but anytime I was there at the office at night, I would see them. Actually, I'm looking at the time now, it's 8:25. I have a friend who has an experiment at 9 p.m. and they want me to come help them. So I have to go do that in 30 minutes, but not right now. So yeah, some people do work really late. One benefit of working late is that your some of the tools that we use, if they're really booked, because they're shared facilities. So if you need a tool and it's booked all day long and the only time it's available is at night, then you're more likely to work at night because that's when like the things you need are available. But if you're proactive enough and can get that slot like in during the day, then you could work during the day. Um, but I know some people who definitely work the PhD like a 9 to 5 as well, though. Just show up at 9 a.m., leave at 5 p.m., have perfectly normal schedules. It's just kind of determined from person to person, and their preferred working style, I would say. But I do know a lot of people who prefer to work later in the day. I definitely know about that.
Yeah. So next, I wanted to ask you a bit about diversity in STEM and what can be done to continue to improve it.
Yeah, yeah. So that's actually a topic I'm pretty invested in. I've been doing a lot of like written work, but also like outreach work within the university, trying to like improve that. Um, it's something I think about a lot and have been talking to a lot of experts because and trying to like build out my network because, like I mentioned, I'm interested in going to academia. And I do see some things about the structure of academia that could definitely be changed to better suit student needs. Because at the heart of it, a research institute is like driven off the energy and the drive of like those graduate students. So if those graduate students are not having a good time, like the research is not happening. So I think it's like like within the interests of everyone involved to make sure that the grad student experience is as good as possible to continue to like create new grad students to continue academia like as a structure. And so I'm really invested in making that happen. I work a lot with the EII office at Stanford, which is the Equity and Inclusions Initiative. It's umbrella under the student services within engineering. And I work really closely with the admin there, and try to do outreach. So sometimes I'll go to universe conferences. So I'll table with Stanford and have people come up to the table at career fairs. That's usually where we have our tables, as at career fairs at different conferences. And one conference that I just went to was NESB. I think before we were talking a little bit about Favor. You said you interviewed before. Favor was actually, Favor is also in electrical engineering at Stanford. She came in 2 years after me. So I think she's probably going to be going into her fourth year now. She was president of the National Society of Black Engineers for a bit. But yeah, that's the conference that I was at. And it's a really great experience to be able to table and see all the different folks that come up to the table who um, are really nervous to even talk to someone who's wearing a shirt that says Stanford because they don't think that they could see themselves there. It's like a really interesting experience because like people will show me their resumes or show me like their experiences and like this is like what I have from college and these are my grades and these are my experiences and I'm like you are definitely qualified. You're more than qualified. I think just some people have that barrier of confidence that they're so uncertain about things that they might not just go for those reach goals, which I think it's good to like make some, I guess, quote unquote safe options, but it's always good to like go for like don't be the person that limits yourself. You can let that the other party basically tell you, oh, like we do or not do not accept you at this time, but kind of like not putting that opportunity out there is just like limiting yourself in a way. You're basically blocking your blessings is what I would say about that. So I try to at conferences encourage people to come up, have a conversation with me. And if I see people looking at me and walking by, I call them over so we can have a conversation. And I like doing that at conferences, just in my everyday life. Like if people like, I mean, you messaging me, you messaged me wanting to talk to me about my experiences. Like, of course, I was happy to say yes because I love sharing like the knowledge that I've gained. And not everybody like has those opportunities to uh, um, know like the tricks of the trade and like how to figure out things before like getting in that position of actually doing it. And I think as much preparation as you have can make you the most successful. And if you know what you're doing and how to get there, it's a lot less scary and a lot more straightforward. And I think that that's the most important part about increasing like diversity within universities is um, to like keeping the cast open to everyone who's interested in these things and then give them a shot to like show what they're capable of because some people don't end up in these spaces just because they were never given the opportunity and I am really grateful for like all the opportunities I've been given and want to basically pay that forward and make sure the next generation like anyone who's interested in science can get into that field because it's really exciting.
Yeah. All right then. Thank you for joining me on the podcast today.
Yeah, no problem. Thank you for having me.